So now I'd like to introduce today's speaker. We have Dr. Jaspreet Sidhu. She's a vegetable crops farm advisor with the University of California Cooperative Extension in Kern County. Today, she's going to be speaking on carrot production and pest management in the Central Valley. And so now I'm going to go ahead and pass this over to Jaspreet. You can go ahead and share your slides.
Thank you, Cheryl. Thank you so much for the introduction, Cheryl. Good afternoon, everybody. I'm Jaspreet Sidhu. I'm the Veg Crops Advisor based in Bakersfield, Kern County. And today I will be presenting on the carrot production and pest management in the Central Valley. And carrots is one of my main commodities that I work on. And this is the overview for the presentation today. First, I'll just briefly talk about some fun facts and production statistics in the Central Valley. Then we'll move on to carrot production, and followed by pests and diseases, major ones, and then we will end it with the poll questions. So for the fun facts, before I begin or delve into the carrot production, I would begin by emphasizing on the importance of America's farming sector on a global scale. So US farmers are really productive, and they're one of the world's most productive, and the number of people fed by the US farmers have been constantly increasing since 1930s. And as of now, a single US farmer produces food and fiber for 169 people in the United States and on a global scale. That's how the America's agricultural sector is important. And now the fun facts about carrots. According to the Vegetables and Pulses Outlook 2020, carrots is one of the most important fresh vegetables, and it's the sixth most consumed fresh vegetable in the United States. And in 2022, an average person consumed about 8.4 pounds of carrots per year. So when we talk about carrots, what comes to our mind? An image of long, slender, orange-colored carrots. And that orange color is due to the pigment carotenoids made by alpha and beta carotenoids. But there are other colors of carrots too, depending on the country or the region and people's preferences. There are several colors, like these red ones, which are due to the pigment lycopene, the yellow ones due to the pigment xanthophyll, and these two pigments are derivatives of the carotenoids. And then we have purple or black colors, carrots, which are due to anthocyanins. And these depend on the people's preferences, the consumer market, and the region where the carrots are grown. For example, the region where I grew up, red carrots were the most demanded ones, or they were more popular, while in US, we have a tendency for orange-colored carrots. However, the purple-colored carrots with the exterior purple and the yellowish or orange interior, they are still considered a novelty in some of the US markets. And now on some of the production statistics from 2022. When it comes to the carrot production in the United States, California indeed is the indisputed leader with approximately 80% of the total US carrot production based here, and approximately 70 to 80% supply to the nation's supply. And this showcases the state's favorable agriculture conditions for carrot cultivation. While California, along with Washington and Wisconsin, they take the lead in the nation's carrot supply, there are some other states such as Texas, Michigan, and Colorado that also contribute to the nation's carrot supply. But California is the leader for carrot production in the United States. So we talked about California's leadership, and now a little bit on the trends in carrot production in California from the early 1925. And you can see here it was pretty on and off until 85. And then there is a huge jump here from the 1985 to 1995, and it almost doubled. And this is the era when the concept of baby carrots was introduced in 1986. And by 1987, the carrot consumption, fresh carrot consumption increased by 30% in the United States. And after that, it has been fairly stable, the carrot production in the United States. And as we talked about the California's carrot production, here are some of the main carrot growing regions in California, the regions colored in carrot in red. Monterey County on the coast, then we have the Kern County here in the Central Valley, which is the main producer and almost produces 60 to 70% of the total California's production. And this is where two of the largest producers of the carrots in the world. Bolthouse Farms and Grimby Farms are located here in Bakersfield, where I am, and in the Kern County. And we talked about Kern being one of the major producers. And as I mentioned, a big chunk, or approximately 70% of the carrot production, is based here in the Central Valley in Kern County. And that has been consistent. Now coming on to the actual carrot production in the field. So the actual carrot production, it begins well ahead of the actual planting in the field, and it starts with planning ahead of time, especially for pest management. Soil samples are done for nematode counts and the nutrient analysis a few months before planting. And then the decisions are made on treatments for nematodes or weeds, depending on those tests. And also the decisions are made for addition of compost or soil nutrients based on those analyses. Then after soil preparation, disking, mulching, it comes to the time of planting. The fields are prepped and the beds are pulled with a lister and bed shape. And in the Central Valley for commercial carrot production, 40-inch beds are used, and the carrots are a direct seeded crop. The rate for carrots planting, it depends on the type of carrots that are grown. For example, the cut and peel or the baby carrots, they are densely planted and have a high seeding rate of approximately 5.3 to 5.5 million seeds per acre. Whereas the cellos, or the big carrots, processing carrots, they are planted at low densities of about 650,000 to 750,000 seeds per acre. For planting, either 4 or 6 row planters are used. As you can see in this picture on the bottom right, that's a 6 row planter. And on the left side, on the bottom, that's the lister pulling the beds. And when planting, the seeds are placed in narrow grooves and are lightly covered with the roller attachments when they're planted, just to make sure they're not blown by wind before the first irrigation. One thing to be considered when planting about the carrot seeds should not be planted deeper than 1/4 inch. And sometimes it's very interesting, like the carrot beds can be pulled or the listed and planted at the same time, as you can see in this video. There is a lister in front of the tractor and the planter at the back. And that was very interesting to me when I first saw it. So for the planting, usually they have 5 to 6 lines per shoulder of the bed, and the 40-inch beds, this is the top of a 40-inch beds. On each side, you can see 5 to 6 lines of carrots, and these lines are about 1 inch to 1.5 inches apart. That's a usual for planting, but there could be more lines or less lines depending on the type of carrots grown. For carrots, the seed emergence and germination are relatively slow and can take anywhere between 10 days to 2 weeks at an optimum temperatures. But when the temperatures, sometimes they hit more than 100 degrees Fahrenheit, usually that's what we get more often here in the Kern County or in the Central Valley, it affects germination and can lead to stand loss. So right at planting, the decisions are also made for herbicides and fungicides. Usually the herbicide Lineron is applied as a pre-plant weed control, and that's the standard for the carrot industry. And decisions for treatment for cavity spot, which is one of the main economical diseases for carrot producers, that's also made based on the history or based on the test. And mefenoxam or Ridomil is applied at pre-plant or at emergence. And that's another picture for the 6-row planter in the field. Carrots are irrigated daily before emergence, and then they are irrigated based on the need, and weekly depending on the growth stage. And for irrigation, solid set sprinklers are used, and the solid set sprinklers are also used for camigation to apply fertilizers and herbicides. And that's a standard here in the valley, the solid set sprinklers for irrigation of carrots. Then at the young stage, the fields are dried down and cultivated. Usually the mechanical cultivation is not used in carrots due to the high densities of the crop, but they are cultivated only once when they're young before row closure. And this is a picture, as you can see, of a cultivated field where the field is cultivated in the furrows and in between the two shoulders on the bed. And at this stage, this next application of the herbicide, Liranon, is applied, and then the fungicides may be applied as a preventative for alternaria leaf blight or other diseases. Then it's followed by the periods of rapid growth when canopy fills in, roots bulk in size and develop color. And for a general practice or maintenance, fungicides are, the fields are regularly scouted routinely on a weekly schedules. And then depending on those scouting procedures, decisions are made on if we need fungicides, when they're needed, or if we need the follow-up fungicides late in the season. But at this stage, later when the carrots have full canopy, the row closure, weeds are not usually a problem for carrot production. Then comes the carrot harvest. Most of the carrots are mechanically harvested with harvesters that can harvest multiple rows at a time. The harvester equipment undercuts the carrots, and while the gripper belt or the belt on the harvester grasps the foliage and lift the roots from the soil. And the foliage then is removed and discarded in the field itself, while the roots are conveyed or the carrots are conveyed into the semi-trailers or wagons. And those wagons or the semi-trailers haul roots to the processing plants. So one thing I would like to mention here, we will be talking about it later when we talk about the foliar blights, that a strong foliage plays an important role in a very good and successful harvest. So once the carrots are harvested, they're hauled back to the processing plants. And we have two processing plants, or the producers that I mentioned, Bolthouse Farms and Kimby Farms, located here in Bakersfield. So they're hauled back, they're bulk washed and graded at the processing plants. And this is just the processing plant, how the carrots are processed inside. And after that, this is what we see in the market, or we get in the market. Different kinds of products, like we have baby carrots, we have chips, we have the shredded carrots, and we have the long carrots or the juices. And this is the whole story of the carrot from farm to table. And that was all for the carrot production, just a brief overview. And now we will be moving into the next step of our presentation, which I'll be covering on major pests and diseases. And there are several pests and diseases that could affect carrot production. Root knot nematodes, cavity spot, alternaria leaf blight, and bacterial leaf blight, cercospora leaf blight. And then we have other diseases. But I will be talking more about the root knot, cavity, alternaria, and leaf blight, where we bacterial leaf blight, where we have done some trialing as well. So the first most economically important pest for the carrot production is the root knot nematodes. And there are 4 different species of root knot nematode present in California that could affect carrots and other vegetable crops. Those are the Lidogyne haplum, Lidogyne incognita, javanica, and arenaria. And they're quite widespread in warmer, lighter texture soil that we have here in the valley. When we talk about the symptoms for carrots, in general, carrots are a moderate host when we compare it to other fruiting vegetables like tomatoes or melons. But the extent of the damage is more pronounced in carrots because the damage is directly on the marketable produce. That's why it is very important, and the thresholds are very low for carrots. The above ground symptoms, they're not very specific, but could appear in the field as stunted or less vigorous plants. The usual symptoms are on the roots in form of galling and sometimes forking and stubbing. As I mentioned, because of this reduction in quality of the marketable produce, they lead to economic impacts for the growers, and they also predispose the plants to other pathogens as well. Sometimes it could also lead to transportation of excessive dirt to the processing plant, which increases the cost of processing as well. Next, what are the challenges in management for root knot nematodes? Crop rotation, first of all, it's not a viable option because of the wide host range of the root knot nematodes. And as of now, we do not have any resistant cultivars in carrots, but we may be getting some soon. And even if we have some resistant cultivars, there could be incidences of resistance breakdown like we are seeing in tomatoes, which has the MI gene resistance. So we cannot rely on just single strategy that host plant resistance will solve all the problems. Management in the past has relied on pre-plant fumigation, which is expensive as well as has environmental concerns. And there are new fumigant regulations by Department of Pesticide Regulations, which limits the amounts of fumigants used by a grower. It puts the caps on the amounts allowed in a township and has expanded buffer zones, which means there will be some areas in the field not treated, or maybe some entire fields are left untreated. And there is also discussion on completely phasing out the fumigants in the near future, and which could be around the corner. So we have concerns about the management of root knot nematodes. And with all those challenges in mind, we have been doing research trials on alternatives to fumigants for managing root knot nematodes in carrots and other vegetable crops. And what we have been doing is basically focusing on these 4 conventional products: Nimitz, which has an active ingredient fluorosulfone from Adama; Vellum, active ingredient fluopyrum from Bayer; fluozendolazine is active ingredient for Slibro from Corteva; and there is another developmental product from Syngenta, which we don't know the active ingredient yet. And we also include some organic options in our trials for the organic industry, just to look at their performance and efficacy. All of these new products, some of Nimitz is registered for use on carrots, while Vellum and Slibro are not. But we have been looking at their efficacy and then their performance in our trials. Because these new products are less toxic, they're highly selective and safer to use, and can be classified as true nematicides, and they only have caution on the label, and they have a novel mode of action. And we have been doing trials on the Shafter Station, research station. These are done as small plot field trials, and we collect data on root galling and also the yields. And this is a scale that we use for rating our carrots from 0 to 10. The carrots in the scale of from 0 to 3, they have like a tiny gall here and there, and they are marketable, or those gall hairs or the galls could be taken care of while in processing. But while the carrots from a rating of 4 through 10 are deemed unmarketable. And here are our results from 2021. The blue bars show the mid-season galling, while the orange bars show the galling at harvest. We didn't have a considerable galling until mid-season, but still there were some differences. And at harvest, damage increased significantly across all treatments, but the 4 treatments, the developmental product from Syngenta, the Vellum 1 is at planting, Vellum plus Watermax and Nimitz, they stood out and had significantly less damage than the controls. Watermax is a soil surfactant that improves infiltration of water into the soil, and we have used it with the Vellum as a surfactant because Vellum has some issues in terms of its motility in the soil. So to make the movement of Vellum better in the soil, we have been using Watermax. And we have had some good success with using Watermax and Vellum together. And next, our results from 2022. In 2022, came along the Nimitz registration for use on carrots in California. And they have 3 rates on the label, varying from 3.5 pints to 7 pints per acre. And we wanted to try both the middle and the high rate. So 5 pints per acre has been our to-go rate in all of our trials that we have been doing. So we opted for a high rate to try like what it does. And Nimitz 2 is 7 pints, Nimitz 1 is 5 pints acre. In this trial, we didn't find a significant treatment effect of Nimitz treatment, but the 2 treatment developmental product from Syngenta and Slibro, they stood out and had significantly less damage than the control. Slibro had approximately 60 to 70% less damage than the controls. 2023 results. Here we had again 2 treatments of Nimitz. Nimitz the lowest rate, 3.5 pints per acre, and our standard 5 pints per acre. We didn't find any significant differences between these 2 rates of Nimitz. They were at par with each other, while the 3 treatments, Vellum plus Watermax, developmental product, and Slibro, they had significantly less damage compared to the control and the organic product from FMC. MB1B1, which is another organic product, it also didn't have any treatment effect on damage by nematodes. And here is a visual comparison of our treatments, the two treatments that were significantly lower than controls. Here we have the developmental product carrots, and here we have the Slibro carrots. And you can see like they're kind of completely clean carrots compared to the excessively galled roots here in the control. So here is another slide showing the side effect of nemats. It's a good side effect, I would say. We have been observing in our trials that nemats, it's a great product when it comes to fruiting vegetables or other crops. It's great. And it has another benefit that it controls nutsedge really well. And you can see in this pictures, it's to the line. Those are the plots from this red flag to the line. That's where we applied nemats. And this is not a nematicide trial. This is just a regular area where we wanted to see like if it actually does it, because we have been observing that benefit from the use of nemats, that it controls the nutsedge really well. That's a really good thing, a positive thing. And it's a great product. It's a great nematicide. But when it comes to carrots are really sensitive. Nemats comes with a package, and it has considerable amounts of phytotoxicity that we have been seeing. As you can see in these pictures, the picture on the right is the nemats with 7 pints acre rate, and you can see it completely wiped off the bed. There is no stand, or 99% loss of stand in the high rate. That too, even when we applied it like 2 weeks before planting. And on the left is the 5 pints age. I mean, there are carrots there, but we still have some stand loss from the use of 5 pints per acre rate. In the 3.5 pints acre rate, the stands are better, but we still lost some stands. And we have been applying nemats 2 weeks before planting. We had tried like 20 days before planting, but we are still seeing some levels of phytotoxicity from it. But we are working on its application methods, different techniques, so that it can be useful or being adopted by the carrot industry. But as of now, it's not something that I would see its adoption by the carrot industry. And to summarize, nemats is registered on carrots in California. It has only caution label, no re-entry interval. But as I mentioned, we need further research to improve the application and thereby the performance in carrots. Vellum, it's a good product and provides good protection against root knot, but further optimization is needed. Slibro and developmental products showed good potential in these trials, but we are still not sure on the registration status. Slibro, I'm hopeful it will be registered soon, maybe probably by next year. And developmental products, it's a couple years down the road that we will see a registration. But those two products, they have been holding good and they have been performing well in all of our trials since 2021. So that was for the root knot nematodes. Moving on to our next pest, the cavity spot. It is one of the most economical soil-borne diseases for carrot producers here in the Central Valley. And it is caused by several different species of Pythium, but usually 2 are associated with it in California, Pythium violi and Pythium sulcatum. Pythium violi is more common in California. The symptoms, they appear as small sunken elliptical lesions on the carrot root surface, and they can be random anywhere on the root surface, but most often they're on the top half of the carrots. And older mature carrots are more susceptible to cavity spot than the younger carrots. Cavity spot in general, it doesn't directly affect the yield, but it reduces the quality of carrots because of those lesions or blemishes on the surface, and therefore have an economic impact on the growers. Sometimes these lesions, they may be associated with secondary organisms as well, like soft rot could come later or some other secondary organisms. But if they're clean and they are not invaded by secondary organisms, they dry out and then just leave a lateral scar on the root surface. For the above ground symptoms, we don't see any specific or anything associated with the foliage or tops. So only thing is to see it is to dig the carrot and then see it, wash it and see it on the root surface. So there's no way to guess based on the foliage or the feel that it has cavity spot. For the management, it is a very difficult disease to control, I would say. The conventional systems has mostly been relying on use of fungicides, and here are some of the fungicides that are registered for use on carrots for controlling cavity spot. But I would suggest that over-reliance on one product can lead to resistant development, and we have seen some cases that resistant to ridomil is seen. So the rotation to crops and chemical chemistries is very important for long-term management of cavity spot in conventional systems. Management in organic systems, it's extremely challenging because of the limited options and the wide host range of the pathogens. Therefore, we have been also doing trials on fungicide screening for cavity spot to evaluate new and older chemistries. And this is our data from 2022. We tested Lifeguard, which is an organic option. Promax is another organic option. Reason, Ridomil, those are the two conventional products. And Nimitz, we just threw in there to see like what it does to cavity spot, because I just wanted to see like what it does, if it does anything to cavity spot. We didn't see any effects of Nimitz. There were no statistically significant differences. However, the treatment Reason had numerically lower damage than the other treatments. Our 2023 data, here we had 4 organic products, Ridomil, Regalia, Stargus, Holler, and Zonix, along with Ridomil, which is a standard, and Reason, another conventional product. And again, Reason was still numerically lower, about approximately 40% less than the control, while the 2 organic options, Stargus and Holler, they all also performed well. We continue to screen these organic products, and it's been an ongoing project. And we have collected the data from 2024, but I still have to analyze it. We're also part of the USDA project, where one of the components is screening breeding lines for cavity spot resistance, which are coming out of Dr. Phil Simon's carrot breeding program. And this year we are going to look at 60 breeding lines to cavity spot, and we will be selecting resistant carrots that will be suitable for production in California. And this is a collaborative project which has been conducted at multiple locations, one in Canada, another location in Washington, and then in California. And based on our previous experience with the cavity spot screening, we have observed that some purple colored varieties are more resistant to cavity spot, and generally the reds are more susceptible. And this is also an ongoing project. Next comes the foliar blights in carrots. And this is one of the most difficult groups of carrot diseases that we deal with. And they're easily noticeable. You can see it in the field from a distance, but they're often hard to diagnose, like what pathogen is causing it, because the blight symptoms are very similar. So there are 2 fungal pathogens that cause foliar blights, the Alternaria leaf blight and Cercospora leaf blight caused by Cercospora croti. And then we have a bacterial leaf blight caused by a bacteria Xanthomonas campestris. First, I'll talk about Alternaria leaf blight, which is caused by Alternaria dulce. It's most common, yet a significant problem for the producers in California. And usually the disease affects the older leaves first, but it can quickly progress to the whole foliage or the young foliage as well if the conducive conditions persist. And infections or the symptoms usually appear as dark brown to black necrotic lesions along leaf margins and petioles. And these lesions later on enlarge and expand to kill the whole leaves. And in severe cases, the field will have a scorched or blackened or burnt appearance. Alternaria, just like cavity, it does not affect the carrot roots, but indirectly affects the yields, because as I mentioned during my harvest slide, that strong foliage or tops are needed for a successful harvest. And Alternaria affects the tops, and these weakened tops break during mechanical harvest, leaving the carrot roots in the soil, thus affecting the yields. And this is just a field with lots of Alternaria. As you can see, the older leaves or the lower foliage appears burned or dead on the beds and here on the irrigation lines as well. Sometimes, as you can see here, the tops regrow after the older foliage is totally dead. But these tops are not strong enough to be pulled by the harvesters. So the yields are still impacted. Some notes on the disease development. It's a seed-borne disease, and infected seed is the most important component or factor that helps in establishment of alternaria leaf blight in new production areas. And once it's established, it could be spread to the new fields by spore movement. And here in this picture, you can see a completely burned foliage in carrots, and this is another picture showing the field from a distance. So how does the spore movement happen? It could, the spores could be wind blown and may come from old field to the new young fields. The fungus also survives on carrot debris or volunteer carrot plants. So that's another source of inoculum. And it could also be moved around with harvesting equipment or on irrigation lines when they're moved from one field to the other field. Coming on to the management, since infected seed is a source for it, we should start with clean seed, and that's a fundamental to integrated management of these seed-borne pathogens. Removing volunteer carrots or cleaning the equipment between fields may be helpful in reducing the introduction into new fields. And we should avoid planting new fields of carrots nearby the older fields, carrot fields, which could serve as a source of inoculum or spore movement. And it's difficult to control, but making sure the old carrot debris is soil incorporated and is fully decomposed before the next sequential plant. Crop rotation for 2 to 3 years may be helpful, but most of the times the growers have been relying on fungicides, and that's a primary strategy. But it's only helpful if the fungicides are applied at an earlier stage or at the onset of disease, because when the canopy is full and dense, it's hard to get proper coverage with fungicides, and they may be ineffective in managing the leaf blight. And because the conventional growers, they have some options to manage alternaria. The organic growers have limited options. So with that in mind, we have been doing trials, again on screening organic options for the organic growers. And the main purpose was because there is only limited amounts of data on the efficacy of organic products and the lack of consistency in their performance. So this is a data from one of our trials that we did in 2022. We had these 5 organic products in the trial and untreated control. And this slide shows the percent diseased foliage in different treatments over a period of time. And as you can see, there was a huge jump. We started to see disease by late June, and by late July to early August, we saw a huge jump in the disease progress. And as you can see, the percentage of symptomatic foliage was the highest in the untreated control compared to other treatments. However, the percent disease foliage was approximately, or I would say 30% lower in EcoSwing and Howler than the controls. And similar trends here for the disease development, area under disease progress curve. There were no statistically significant differences among treatments, but the treatments Howler and EcoSwing had lower disease development compared to the untreated controls. Next is our Cercospora leaf blight, often a problem in coastal regions, and young foliage is affected, and they appear as small circular tan to brown spots and curled leaf margins. Management is pretty similar to Alternaria leaf blight, and the same materials could be used for management of Cercospora leaf blight. Next is our bacterial leaf blight, which is caused by the bacteria Xanthomonas campestris, and it's problematic in certain production areas such as in Antelope and Cuyama Valley. It is very difficult to distinguish from Alternaria leaf blight because the lesions look similar. They begin at the margins of the leaf blades, they become necrotic, and they're with the yellow halo. So the lesions look pretty similar. But one of the characteristics for it is the petiole lesions are brown, and they often have the bacterial ooze or the bacteria coming sticky substance coming out of the cracks on the petioles. Therefore, even the plants that have bolted or have flowers on them, they have the bacterial ooze coming from cracks on the stalks. And that's a characteristic diagnostic feature of this disease, which can be usually seen. However, a proper diagnosis is needed before decision-making on treatments. And here in this picture on the stem, you can see the bacterial ooze coming out of the cracks. And here on the flower, you can see the bacterial ooze on the stem and the flower as well. For the management, as I mentioned, clean seed is the fundamental. The hot water treatment or the treatment with seed treatment with fungicides can reduce incidence of bacterial leaf blight. Cultural practices such as incorporation of carrot debris or crop rotations may be helpful. And copper-based bactericides are recommended or used, but they can slow the development but will not eliminate the disease. And that is true for any foliar blight. There have been concerns about resistance development towards copper in Xanthomonas. And with that in mind, we have been doing field evaluations of existing chemistries for management of bacterial leaf blight. And this is our data from 2022. So here in the final sampling on April 18th in 2022, the treatments Coeva had the lowest pathogen population, and it was followed by Nordox and Coside. And these levels were lower than the levels of colonization of the bacteria needed for the development of symptoms or in the field that you can see. And for the area under disease progress curve, we saw significant differences among treatments, and the treatments Coside, Lifeguard, Coeva, and Nordox had significantly less area under disease progress curve compared to the non-treated controls. And this is the data from 2023. I haven't looked at the statistical analysis yet, but would like to mention here that a combination of Nordox and Lifeguard, they had significantly less pathogen populations at sampling number 3, 4, and 5. Our next disease, moving on from the foliar blights, is the soft rot, or it's on the carrot root, the below ground parts. It's another summertime disease and occurs when the weather is hot, and then we have to constantly irrigate the fields. Usually the infection occurs in the field, but it may show later in the shed or in the processing plant. This is recognized as a soft, watery, and slimy decay of the carrot root. As you can see in the top picture, that's like a carrot melting with soft rot, and it is accompanied by a foul or bad smell. And soft rot could be secondary as well. It may not be the primary cause. If you have other pathogens, soft rot usually comes as a secondary. And this is the soft rot on baby carrots later in the storage. And a few pictures on soft rot, carrot root melting in the field. And sometimes if you have soft rot right before harvest or at mature carrot, they just melt in the field. Nothing comes out. And this is a dried soft rot on a carrot. So for management, proper drainage or eliminating low spots in the field will be helpful. Proper irrigation management, avoid overwatering carrots during periods of high temperatures, especially if the carrots are mature or near harvest. And to minimize the post-harvest damage, avoid bruising or wounds to the carrot roots during harvest and during processing. And using chlorinated water to wash and the carrots will be helpful, and then storing under cool conditions. Another summertime pretty big disease is southern blight, not for carrots, but for other crops as well. It's a big disease in Kern County. Historically, it used to be only in Kern County, but there have been more and more incidences up north in other counties as well. So as I mentioned, it's hot weather disease, and the temperatures high in the ranges of 85 to 90 degrees favorite, high soil moisture, and frequent irrigation, which we usually have in summer, aids in the disease progress. And this disease, the characteristic, easy to diagnose, the most easiest one for me is this one, because you can see the mycelial mat at the base of the plants, and the mycelia has a characteristic growth pattern, like it grows in a fan-shaped pattern at the base. And then accompanying it with it are the numerous tan to brown colored mustard side sclerotia in the field. This is easy to diagnose, but the most hardest one to manage or control. And another picture of the sclerotia at the base of the plant, and this is a carrot root with 2 diseases. It was affected by southern blight at first, then the soft rot comes in as a secondary pathogen. And that's the mycelium, white mycelium on a carrot root, along with some sclerotia. So management, rotations may be helpful with small grains for at least 2 to 4 years. Deep plowing to bury the sclerotia may be helpful, and then burying the plant debris helps in destroying sclerotia. Those are the cultural practices that may be helpful, but fungicides have been used. But again, like other diseases, the use of fungicides, it's challenging to manage it with the fungicides. Because of the larger canopies, dense canopies, it's hard to get to the bottom of the plants with those fungicides. So that's why the fungicides are mostly rendered ineffective at the later stages when the disease shows up. A similar disease to southern blight is the cottony soft rot, but the main difference is the southern blight is hot weather. This is a cool weather disease, especially in the fall. That's when we see it, and it's favored by low temperatures in like 55s to 70s, but it can occur at any growth stage. And again, it has just like southern blight, it has the cottony mycelium growth at the base of the plant, and it's also accompanied by black colored sclerotia, but those sclerotia are much larger than the sclerotia produced by the southern blight fungus. Those were like mustard size, and these are like the size of a cotton seed. And the rot that's caused by the sclerotinia, it's usually soft and watery compared to the rot caused by rhizocotonia on carrot roots. And it's not foul smelling as the soft rot is. And this is the sclerotia, the large cotton seed size sclerotia, and these are some of the sclerotia and the mycelium in the field, and this is another close-up of the sclerotia. And here is the comparison of sclerotia for southern blight and white rot. As you can see, these are small, tiny sclerotia compared to these big ones in white rot. And this was, again, a soil-borne disease, so deep plowing may be helpful, but it may not completely eliminate it or control it because the spores may be blown in from other fields. Crop rotations, like other diseases, may be helpful in reducing the inoculums in the soil. And then trimming carrot foliage after the canopy closes aids in better air circulation, which could be helpful in managing the disease to a certain extent. And then one of the main things that we could do is avoid planting in the fields with a history of cottony soft rot or white mold. Then comes the black root rot, another Alternaria pest of carrots, but it is caused by Alternaria radicina, and it's even harder to manage compared to Alternaria dulce, which is the Alternaria leaf blight. And again, it's seed-borne. The pathogen can survive on carrot debris, and the spores can survive in soil for several years, and sometimes in some studies they survive for about 8 years. And older mature carrots are more susceptible, and high moisture and warm temperatures favor the disease development. So the disease usually starts in the crown or the shoulder region of the carrots as black lesions on the base of the petioles, and these lesions later extend into the root, causing the characteristic black crown. And the tops are weakened, which affects the mechanical harvest, and then the yields are impacted, just like Alternaria leaf blight. For management, as it is a seed-borne disease, starting with certified clean seed is the basic step, because once it's introduced into the field, it becomes a soil-borne pathogen. Then the other cultural practices such as deep plowing, incorporation of crop debris may be helpful. Fungicides, just like Alternaria leaf blight, bacterial leaf blight, it is challenging because it's a late season disease. When the canopies are full and dense, it's hard to get the fungicides to the base of the plant. Root dieback, which is another term for forking and stubbing. It's another serious concern for carrot growers, and if the young taproot is infected at an early stage, 2 to 3 weeks after germination, the taproot is either reduced in length, which is called as stubbing, or it could lead to multiple root formation, which is called as forking. So it's basically caused by damage to the growing root tip when they're young, and it is often attributed to 2 Pythium species, Pythium ultimum and Pythium irregulare. But there may be other factors as well that could lead to stubbing and forking: poor soil structure or soil compaction, improper irrigation management, hard freezes, nematodes, and rhizome. They could also lead to similar symptoms. Therefore, a proper diagnosis is recommended, and then start with good soil tilth and proper drainage. Another minor disease is the powdery mildew, which is not a big concern, but if it infects the crops at early stage, it can cause significant losses. And in the field, it appears as white powdery fungal growth on the leaves and petioles, and the infected leaves may exhibit some type of yellowing or chlorosis as well, as you can see in this picture. And this is about white powdery growth on the leaves in the field. Chemical control, it's not usually needed, and there are some cultivars that are resistant to powdery mildew. But maintaining a good plant vigor and using the resistant cultivars can minimize powdery mildew. And this is how it appears in the field, visible from a distance as whitish patches or foliage in the field. And you can clearly see this patch whitish looking compared to this on the left or the right side. Another concern is the seedling damping off, which may be caused by several species of Pythium, Rhizoctonia solani, and other soil-borne fungal pathogens. Damping off leads to poor seed germination, root dieback, or seedling death, and eventually poor stand. It could affect the seedlings even before germ or after germ. And if the infection occurs after seed emergence, it usually occurs at the soil line and causes a stem girdling or pinching at the soil, which is visible. And the infected tissue is reddish brown and water soaked. And here in this picture, it's not quite evident, but this is where the constriction of the stem occurs at the soil line. And based on my experience, rhizoc in field, it affects the carrots, young carrots, when the area of the field goes too hot and dry for a certain period of time. And when you run through the canopy, the tops will fall off. They're so much dried. And that's what I have learned based on my experience, that rhizoc does that to the young carrots. Minor concern, crater rot by rhizoc. I have seen a few times here in the last few years. Usually a dry rot, but if secondary organisms are present, then we can have soft rot as well. Characterized by sunken lesions, as you can see on the root surface, and usually have white mycelium closely associated with these lesions. Scab, which is caused by another bacteria, Streptomyces. It can cause pitted and corky lesions on the root of the carrots. And these lesions are typically horizontal on the carrot surface. They may or may not occur in the carrots following a potato crop, which is another susceptible host for Streptomyces. The viruses, another group. One of the main concerns, or the one that we have seen, is the carrot motley dwarf, and it's mostly in the cooler growing regions. It is caused by a combination of two viruses, carrot red leaf and carrot mottle virus. This virus is affected by the environmental conditions and the growth stage of the plants. If the young plants are infected and the weather is cooler, it leads to reddening or yellowing of the leaves in the young plants, as you can see in these pictures. And the carrots will be extremely stunted and woody. But if it affects the older carrots and the warmer climate, we don't see much symptoms or much effect on the carrots. It is transmitted by the carrot willow aphid, which has a narrow host range, just like the viruses. And both viruses, they can infect the carrot plants individually, but together their presence as a group is needed for the infection to be visible. And they have a narrow host range too, just like the aphid. For treatments, we should avoid planting near the older fields because there are no alternate hosts or weed reservoirs that can serve as the host for this virus, because they have a very narrow host range and need the carrot plants to feed and reproduce. And that's for the virus. Another one is the aster yellows and the beet leaf forward transmitted virulent agent. It leads to the severely distorted and malformed flowers or umbels in the carrot plants and thin woody roots with many proliferations of root hairs. That was it for the pests and the diseases and the carrot production. And these are some of the resources that could be used for information. We have publications from UC, we have pest management guidelines, and then UC Cooperative Extension can be contacted for field calls or diagnostics. And that's me here in the Valley in Kern County. And that's my email there, my phone number. You can always call me for sampling, for field calls, or for any diagnosis of the samples, and that's a free service. With that, I would like to say thank you for your attention, and I'll be happy to take any questions.
I have a couple questions on the production part of it. So one question is, what is the best soil for planting carrots? Sandy or loam?
Sandy loam, I would suggest that's the best that we have here in the valley.
Okay, thank you. And then another question was, is this a cool season crop? Would you plant for the winter months?
Well, in California, it's a year-round process. We have 2 crops a year. One is like planted in the fall that we harvest in the winter, and then the other one is planted during the winter months for harvest in the late summer.
Okay, thank you. And then I think this question came in when you were discussing the root knot nematode control. So somebody was asking, are those the same phytotoxic issues? Are those same phytotoxic issues the reason why it works well on controlling nut sedge?
Well, based on my experience, it's not, because we have like different kinds of weed pressure at the farm or in the trial areas, and it's affecting only nut sedge. So if it's the phytotoxicity issue, it should be uniform across all weed species, but it's basically the nut sedge.
Okay, thank you. And then another nematode control question. Have you looked at Melicon and Nemaclean for nematode control?
No, unfortunately, so far I haven't looked at Melicon and Nimaclean. We will be looking at Melicon in the next year's trials.
Okay, thank you. And then for foliar diseases, there's a question, have you looked at polyoxin D for foliar diseases?
No, we have not, but would love to if I could get the product.
Okay, I'll ask just a couple more here and then we'll have to share the final test link. But are there any nutritional differences between the different colored carrots?
Yes, based on those pigments, because reds are good in lycopene, while the yellows are good in xanthophylls, and the purple carrots have anthocyanin in them.
Okay, and then I think just this one final question. What is the #1 challenging insect infestation for carrots?
Recently, I think we have been hearing about flea beetles. But other than that, in the area that I am, sometimes the aphids or crown aphids, those could be problematic, but usually mostly it's a disease pressure.
Okay, thank you. And so Peter has posted the link to the final test in the chat, and maybe I can just do one final question. I know we have a few left, and I don't think we'll get to the rest, but let me just do this one. Does fungicide application manage Pythium in early phases of growth?
That one I would have to say, like, which Pythium are we talking about? Yes, if we're talking about cavity spot, early applications of Ridomil or other recommended fungicides will be helpful, but we still need late in-season applications.
Okay, thank you. Thank you so much for your presentation. It's a lot of information, a lot of good information.
Yes, it was a lot to digest in just one presentation, but there's no other option to split. We could have split it into 2 different series. Yes.
Yes, so thank you. Yeah, we really appreciate you coming today and presenting. But thank you again, Jaspreet, for presenting today. And we do appreciate everybody for attending.
Thank you for the opportunity, Cheryl. Thanks.
Thank you. Have a great afternoon.
You too.